Another class. I'm Dr. B, your chemistry, in fact, your science teacher online. And today, you and I are going to do justice to this topic, subshells and atomic orbitals. Subshells and atomic orbitals. Quite an interesting topic today that you and I will be discussing under chemistry. Alright, now do not forget that you owe me a duty to ensure that this class is being shared. Okay, and then you also ensure that as it's shared, you tell those people you're sharing it with to do what? To subscribe if it's through YouTube, or to follow if it's through what? Facebook. Okay, so you can also leave comments, either questions or just comments or appreciation, and you can also like as well. The YouTube name, channel is simply Dr. B Science Classes. The same Dr. B Science Classes for Facebook. Alright, now subshells and atomic orbitals. Now with the diagram that you find here on this board, it resembles something that we commonly know. Commonly we are aware of that. And this is somehow like the sun having the planets around it. Okay, that is something of this nature. Alright, so the nucleus here appears to be like the sun, which is at the center, and then electrons are orbiting around what? The sun, just like the planets, okay, are revolving around the sun. That is a typical way that you can see an atom. Okay, an atom looks like that. Okay, with the sun and the planets, the same thing like the nucleus and the electrons. Now the only difference that you get as far as that is concerned with this particular atom is that in the atom, electrons are not fixed. They are not in fixed position like the planets are. You know, the planets are in the fixed position revolving around what? The sun. Now it is not the same with the electrons that we are trying to compare them with the planets. Electrons are not actually at a fixed position and then doing what? Orbiting this particular nucleus. That is just the difference. Otherwise, it's almost the same thing. Okay, the description is almost the same thing, except that electrons are not found at fixed position like planets are found at fixed position revolving around what? The sun. Okay, so we have here a typical atom, and then at the center here is a nucleus, and it comes to know that the nucleus has charges. Okay, the nucleus has a proton and it also have a neutron. Okay, so in this nucleus it has a proton which is positively charged. It also has what? A neutron which has no charge. I hope you know that neutrons have no charge because they obey the electron neutrality law, because they have the same number of charges in terms of negative and positive, so they cancel out, so neutrons are actually neutral. Okay, so the nucleus has both proton and nucleus, proton and neutrons, and then it has electrons that are found around the shells, and then they are orbiting around the nucleus. Now, do you know that a typical atom, as it is, possesses what we call shells? Okay, and these shells are also described as energy level. Yes, the shells are described as energy level, and that is why if you look at the nucleus, you have these cycles around. Each of these cycles describe a shell that is energy level. So we can possibly say that this shell is described as energy level. Energy level. Okay, so you have energy level 1, you have energy level 2, you have energy level 3, you have energy level 4, and continuously they count. Okay, now these energy levels you see here possess some amount of energy. So the farther away the energy levels, the higher the amount of energy. Okay, the farther away these energy levels, the higher the amount of energy. Okay, it will stay away from what? From the nucleus. Now we have energy level KLMN. At least for now, that is what I'm going to tell you. That we have energy level which is shells in an atom as KLMN. But something striking, if shells are energy levels also have what you call sub-energy levels. Alright? So each of these energy levels you see here, KLMN, also have sub-shells, that is sub-energy levels. And this sub-energy level play a very crucial role in the reactivity of every atom. And this is because each of these sub-energy level also possess what we call orbitals. And for every subshell that you have, there is an orbital. Some have one orbital, some two, some three, as the case may be, depending on the type of subshell that you have. So one could just say that we have energy level KLMN, that is shells of KLMN, and for a particular shell or energy level, let's say the first energy level, which is the first shell here, possesses what? Possesses a subshell, which is called what? The S. And remember that subshells are either S, P, D, or F. These are subshells, S, P, D, F. Now, if you cast your mind back to the class we had earlier concerning shapes of molecules, you'll see that the shapes of this particular S, P, D, F subshells were all drawn. They were explained exhaustively and drawn. That particular online lecture is there. So you can go there and get yourself abreast of that particular lecture, have knowledge on it, then come back here. Okay, so if it is the second energy level, which is the second shell, then we are going to have two subshells. And that is why you have two here, two subshells. And of course, the first energy level, which is the first shell, K, has one subshell. That is one sub-energy level. And then the second energy level, or the shell, has two subshells. And then the third one, N, has three subshells. And then the fourth one, N, as the shell, also has what? It has four subshells. Okay, now we are told that each of these subshells contained in this energy, in this KLMN shells or energy level, also possesses what you call what? Orbitals. But what is an orbital? If we understand that shells simply means energy levels, what are then orbitals that are found in the subshells? Because the subshells are divided also into orbitals. I want us to know that in the modern theory of an atom, Edwin Schrödinger had let us understand the fact that electrons are not found at a particular or a fixed place around the nucleus of an atom. That is one of his postulations in the modern theory of an atom. And he let us to understand that electrons can only be found at high probability just around the electron cloud. Okay, so when you look at what an orbital is, an orbital is simply, it's simply being seen, okay, as any point at all, okay, any point at all around the nucleus where there is a high probability, sometimes probability of about 90 to 95% of finding electron at that particular point. That is an orbital, okay. Any region of space where there is a high probability of about 90 to 95% of finding electrons at that particular area is described as an orbital. So it means that when we say that each of these subshells have orbitals, it means those orbitals are where you can have a higher probability of finding what? Electrons. Now, I want us to know that these orbitals that we have for each of these particular subshells holds or house a maximum of 2 electrons. And this is the description this way. So now this is the process. You have the K shell or energy level that possesses one subshell. And that one subshell is the S. S is the subshell. But the S as a subshell, which is only one, carries just one orbital. And this one orbital has 2 electron maximum, because each orbital can only possess maximum of 2 electrons. And that is why you have the 1s orbital. Okay, so when you hear 1s, 1s2, 1s1, or 1s2, 2s2, 2p6, 3 this and that, you are describing the number representing the subshell and the orbital itself, and the number of electrons that that orbital is holding or is carrying. Okay, so we have the K shell as energy level possessing one subshell, and the one subshell possesses one orbital housing 2 electrons. So one can say that hydrogen, for example, has 1 electron, and it is 1s1. You see, which means that hydrogen with 1 electron belongs to what? Belongs to the K energy level of the shell. And then it belongs also to the S subshell with 1 electron. It's deficient, of course. Alright, so that is the description. And now you can also have the L shell or energy level, which has 2 subshells, which are what? The S and the P. And that's why you have the 2s and the 2p orbitals. So here you can see that the L energy level possesses 2 subshells, and the subshells are the S and P. S and P subshells. And you can see 2s and 2p to show you that it is the second energy level or shell. The second energy level or shell possesses 2 subshells, which is S and P. And because it is at the second energy level, we said 2s and 2p. Now, the third one, which is the N shell or the third energy level, possesses 3 subshells. And the 3 subshells are the S, P, and D. And now you can see that because it is at the third energy level, we have 3s, 3p, and 3d. And that's why you have here 3s, 3p, and 3d. But of course, remember that these 2s and 2p that you have here has 3 orbitals with them. They have 3 orbitals with them. So with the 3 orbitals, what do you have? 6 electrons maximum. Remember that each of these orbital houses only 2 electrons. So if the P subshell has 3 orbitals, then it's going to have a maximum of 6 electrons. And that's why you have 1s2, 2s2, 2p6. You cannot have more than 2p6 because it's only 3 orbitals that are in that subshell, which is P, and each orbital houses just 2 electrons. So with 3 orbitals in the P subshell is 6 electrons maximum. And this is because the P subshell has the PX, has the PY, and has the PZ. So this subshell P has the PX, PY, and PZ. And that is why when you are drawing the configuration in order for you to fix in electrons, you see that you have 1, 2, 3 spaces for you to fill in electron, following the Pauli exclusion principle, Hund's rule, and the Hofbauer principle. Okay, now when you come here to the N shell or energy level has 4 subshells, and that is S, P, D, and F. But of course, the F subshell, okay, we are done with the D. Okay, no, so we are not done with the D. So we have said here that the three subshell shells, which belongs to the N or the third energy level, okay, has 5 what orbitals. That is the D, have 5 orbitals. So it means that it has what 10 electrons maximum. You cannot give it more than 10 electrons when you are placing your electrons in their electronic configuration pattern. Okay, now the same thing happens here. So in the last one, which is the N, and the fourth energy level or shell, there are 4 subshells, which is the S, P, D, and F. But of course, the F subshell has 7 orbitals. Okay, has 7 orbitals. And with 7 orbitals, of course, it means it has 14 electrons as maximum. Okay, so that is how it goes, and that is how the arrangement of orbitals and subshells and shells in an atom looks like. So whenever you are looking at an atom and the arrangement of the various orbitals, the various subshells and shells in atom, understand the fact that the atom as a whole possesses first the energy levels, which you call the shells, the KLMN shells. And then in the shells, we have also what we call subshells. And the subshells range from the S, P, D, and F subshells. And the subshells now possess what we call the orbitals. And we said that the orbitals simply explain the region of space where there is a higher probability of finding electrons. So the orbitals now will be arranged in such a way that they match up with the subshells. So if you see a shell which is in the first energy level, first shell will possess only one subshell, and that is the S. And because it has only one subshell, it also has only one orbital. And the second one has 2 subshells, and it has 2 just the way it is. And then you now have the third one, which is the N. It also has 3 subshells, and with 3 subshells, it has 5 orbitals, and so on and so forth. And that is how it goes. Don't forget that this is 1 orbital. All right. So when 1 orbital now come in here, this S is 1 orbital, okay, and the P is 2. So if you add the 1 to the 2, it gives you 3, and that is why the P has 3 orbitals, because you're adding the 1 S orbital to the 2P orbital, you have 3 orbitals. And then if you come up here as well, you can see that these are 5 orbitals. All right, so it goes in that way, consistently goes in that way, and then you finally arrive. Now I am sure that from this class you'll be able to describe the atom, and especially be able to arrange the energy levels of shells, the subshells, and understand also how the various orbitals are also arranged in the subshells, and what are the number of orbitals for each of the subshells, and what is also the number of electrons maximum that each of these orbitals can carry. This has been a very nice class, a very nice time having this class with you. I suppose that you are going to assist me by sharing this class so other people will also benefit from this beautiful work that we are doing. I remain Dr. B, and my channel remains Dr. B Science.